Okay, I wanted to do a joke, and my son told me one, but I can't do it by myself. Ready?
Yeah.
Okay. Knock, knock.
Who's there?
Cargo.
Cargo who?
Cargo beep beep.
Knee slapper.
It's the worst. Um, so I wanted to do another video with you practicing some more of those and then moving on to the real world problems. So here's the exponential equations using other bases. Let's do some more of those real quick. And I'm going to pull that over here. And just like before, the first thing we're going to do is we're going to try and get rid of this 4 because it's the farthest away from the letter T, but on the same side of the equal sign. And that's how we know where to start. It's being multiplied by 4, so we'll divide by 4 to get rid of it. So then we have on the left 2 to the negative t over 5 equals whatever 288 over 4 is. Now I think I can do that one in my head. I think it's 72, but let's double check to make sure I didn't go crazy. 288 divided by 4. Oh yeah, I did it. I get all excited when I can divide in my head because I can never do it. So 72. And then we need to get this t by itself. It's in the exponent. So to get it out of the exponent, then we are going to rewrite it as a logarithm. And the base is this 2. And it equals, I'm recording a video. You want to be in it?
No.
Oh. Okay, well, come here, give me a hug. Squishy. Now she's in it. Oh. Oh, squish my face so hard. And that's all being recorded right now.
I'm just hugging you.
So log base 2, and then the exponent goes over on the right side, so that negative t over 5. And then this little guy is argument, so it goes on the left, right next to the log. So again, remember this part over here is all just something that the certain calculators can handle. Otherwise, you'd have to use a change of base formula. We're just going to use a calculator that can handle it for now. It's not a hard formula. I just don't want to add that in right now. And then we're going to get t by itself. So it's being divided by and multiplied by -1 and divided by 5. So I'm just going to multiply both sides by -5 to get rid of both of those at one time. So I've got -5 times the log base 2 of 72 equals positive t. Okay, so all this on the left is my exact answer. And depending on how they want the answer, depends on if I have to plug in the calculator or not. Turns out I do not have to plug in the calculator because it's multiple choice. So -5 log base 2, log base 72, log base 2, log base 2 of 72. That's the one. Okay, next question. Let's pull this over real fast. Okay, so to do this question, we're going to start again by getting rid of this -15 that's being multiplied out front. It's not being subtracted. So the opposite of multiply by -15 is divide by -15. So we have 2 to the negative 0.5x equals, and then we have -90 divided by 15. I think that's going to be like 15, 15, 15, 15, 15. I think it's going to be 6. Let's find out. -90 divided by 15. Yeah, I did it again. Could divide. So -6. All right, and now to get this x out of the exponent, once again, we will take the log. Oh, let me put it this way. You can take the log base 2 of both sides, which is not a method I've been showing you because I've just been using the definition of rewriting an exponential as a logarithm. So that's what I'm going to do here. Log base 2, it's going to equal the exponent. And we have to take the log of the argument, which is over on the right side. Now to get rid of that 0.5 that's right next to that x, we have to divide both sides by negative 0.5. Divide by negative 0.5. Okay, so those go away. So I have x equals all of this. And if it's one of my answers, I'm good. If it's not, I might have to plug it in. Oh, I have to plug it in, it says, to the nearest thousandth. Alrighty then. So let me pull this over so that I can see what I'm doing. Now, if you try to do it in the calculator that's inside Khan Academy, it only has log base e, this natural log, and log base 10, the common log. Well, the question we're dealing with is log base 2. So those two logs won't work because that's base e and base 10, and I need base 2. So I'm going to cheat, if you will, and use a different calculator that has that option in there. So I'm going to go down to a new line and go over to functions. And if you could go all the way over to these different menus, miscellaneous has log base e, the natural log. It has log base 10, the common log, and it has log base anything you want. And I need log base 2. And I need to do that of 6 and then divide it by negative 0.5. So my answer is negative 5. Let's see, and that says 3 decimal places. So 169, because it says nearest thousandth. Now, this is basically 0.169 thousandths. Well, this 9 up here means I need to bump it up. So instead of 169, I'm going to have 170. So negative 5.170. Let's see if I did it. Boop, boop. All right. So I'm going to skip to the real world problems now so I get all that in one video. So I'm going to close this one. And oh, look, it's telling me I've been doing stuff. Great job, me. My internet was slow. I had the spinning circles of death for a while, so I paused the video. Okay, so I've made a video on that. Now I've started a video on this, or I made a video on that, and I started a new one. And here's this third one: exponential model word problems. So when is anybody using the real world? And actually, some people have been talking about my juniors are using this stuff in chemistry right now. So this says Olivia's taking medicine. So hello, doctors, nurses, pharmacists, what? The relationship between the time t and hours since she took the dose and the amount of milligrams that's still in her bloodstream is this. How many milligrams of the medication will be remaining in Olivia's bloodstream after 6 hours? And this was about time t and hours, so I don't have to switch anything. So after 6 hours. So I need to take out this t and put in 6. Okay. Crazy button. Hit the crazy button. Something is not happening right. The key here is realizing that you don't just look at this and plug in a number randomly. You have to plug in the number in the right spot. So 6 hours is going in for T. So all I have to do, they want to know how much is in there if we take out everything, every T, and put in 6. So all I have to do is plug this into a calculator. Where that T was, I'm putting in 6. So that's what I'm gonna do. And I mean, you can use this calculator here. It works. We can just use that one. So 50 times e to the power of, and I'm gonna put parentheses around this so I don't mess anything up, negative 0.75 times 6 parentheses. And it says round to the nearest hundredth. So right now I've got 55 hundredths, that 0.55. But that next 5 bumps it up. So instead of 55 hundredths, I will have 56 hundredths. Let's see if we're right. Now, I really like Desmos though. So if I wasn't just trying to show you how the Khan Academy calculator would work, I totally would have just used this. And I would have typed in like 50 e to the power of negative 0.75 times 6. Oop, I hit divide or something. What did I do? 0.75 times 6. And it tells me the same answer, right? So it actually goes out some more decimal places than this does. It stops at that 2.6, turns into a 7. This goes out a little bit more, but we don't need to go out that exact for this, so it's fine. All right. So apparently I've done some of these before. So it looked like I only had to do one to finish it, so I'm going to go back in and do some more. You can always go back in and do some more. Okay, so this question is talking about somebody's car and that their value goes down exponentially. And the relationship, T is in years, and here's the equation of what its worth is. And then how many years after the purchase will his car be worth $10,000? So this time, we're not just plugging in $10,000 for the number of years, right? This time we're plugging in $10,000 for the value of the car. So I'm going to do 10,000, 1, 2, 3, equals 22,500. First of all, that's a nice car, better than I ever got. Times 10 to the negative t over 12. And then we're going to solve this just like we did the last assignments equations. So first I'm going to divide both sides by 22,500 because that's on the same side of the t but farthest away from it. Gone. Calculator, 10,000 divided by 22,500. 10,000 divided by 22,500. So I don't like that it's a crazy decimal, but 0.4444. All right. Let me just reduce this fraction. I'll just leave it at 100 over 225 for now, although you and I both know that could reduce more. 10 to the negative t over 12. Okay, so now to get the t out of the exponent, we are going to rewrite it as a log. And I'm going to try and zoom in so I have a little more space to write because I was crazy. So I have log base 10, which means I don't technically have to write that, of whatever 10,000 divided by 22,500 is. I'm just going to write it as 100 over 225 equals the exponent, which was negative t over 12. Whoops, I don't like how I wrote that. Try this again. Okay, so now it looks like we're dividing t by negative 12. So to get rid of that, we're going to multiply both sides by negative 12. So this is the exact answer. T equals all that. But I bet on this video or on this answer, they wanted, oh, give an exact answer. Hey. So that's what they want. So negative 12 log. Now, since this is base 10, I don't have to write base 10. That's the common one. I can leave it blank. Of, but they are totally going to want me to reduce that 100 over 225. So I think the biggest number that goes into both of those would be 25. So this is 25 times 4, and this is 25, I think times 5. Let's double check. 25 times 5. Whoops, hey. 25 times 5. Yep, 125. Oh, that's not what I wanted. Let's try this again. I want 225.